Accessible.
Accessible. I keep saying automated. It's in my head, sorry. They are automated though. But more important, they're accessible. So, you need 2 of them? One more. There you go. Here is the accessible pedestrian signal detail. I don't know why that's in my head. So these handouts that I'm giving you were from the MnDOT ADA guidelines homepage. So if you're looking for additional resources from MnDOT, just go to their MnDOT landing and then Google ADA guidelines, and they have a nice clearinghouse of links and resources for all kinds of information, including this. Almost ready. Do you want these, Todd? Okay. There's 2 together. There you go. All right, so this is not meant to be a comprehensive design class. As I said before, there's one of those coming up in the next few months. I don't believe dates have been set yet. Todd, do you know?
I think February to the end of April.
Right, but we don't have registration. Okay, so the dates have been set. So if that's interesting to you, be on the watch for that. Certainly if you got the announcement for this, you'll likely be able to get the announcement for that.
Will they email it to you? Like if we signed up to this and verified with Mindy?
So the question is, will they email it to you? I have to say, I don't know. So I'm guessing that if you were emailed an announcement for this, you'll be emailed for that. But you could also be watching just on the CTS webpage. Yeah. So we're going to try to make up some time here by going a little bit quicker through the first part. Brady's already talked quite a bit about some of these things that are covered. So you'll have to trust us that you've already seen this or you will be seeing this as we get a little bit further. So the main goal for this section is to go through the standard details and make sure that you know where to look for the design compliance, the design guidance on curb ramps and driveways. As, I'm sorry, I can't read it. I think his name is David from your city of St. Paul.
Correct.
Said, I've been in construction a long time, and you know, we all nod and say, yep, we've seen a lot of plans that say contractor fit in field, grade to drain, whatever. And as an engineer out on a job inspecting, often for Met Council or others, that becomes very problematic because out in the field, you're trying to work with three-dimensional grading and drainage, and you got a contractor who wants to get it done. So unless you're extremely assertive and just say, let's just slow down a little bit, it's hard to do those things quality in the field. So I would agree. I also teach design though, and I know the amount of data collection required to look at every quadrant. You'd have to get gutter grades, you'd have to get topo shots back quite a bit. And if you don't get adequate survey data that goes back, let's say 20 feet up into even more than 20 feet sometimes, you may not have adequate data to match in. So changing the culture of data collection, I think, is an important thing, because a lot of times the only data you get when surveying is down the center of your sidewalk, set down your gutter if you're lucky. So I really appreciate what you said, but there are some limitations there.
Yeah, I would agree, but I think the conversation needs to start.
Absolutely, I totally agree. And I would hope that that get communicated during the design class. So Brady already talked about some of this. Again, we're basing our class today off ProWag and Pro standards. What I'm about to dive into are MnDOT standards, okay? Now, every job you design or every job you build may not be a MnDOT project or may not be a MnDOT right-of-way. Certainly, you may have your own standards. Met Council might have their own, Olmsted County. What we are advocating or presenting is just some vetted, approved standards that you may decide to default to if you don't have others that overrule. So we understand there's flexibility, but the MnDOT standards are very good and show quite a bit of detail. The overriding principle as we go through these are pretty easy. Cross slope must be maintained at no more than 2%. Longitudinal grade at no more than 5, and if it goes up to 8.33, we need to consider a landing and other provisions. And I think that's about it. Those are the two big considerations. We also have to make sure to provide a landing when a change in direction is part of the ramp condition, and when we have a cross or a longitudinal slope that exceeds 5%. So with that, we're going to dive right in. I was at a theater last night. Has anybody been to the Duluth Playhouse in the depot? The cross slope on that, I mean, getting to my seats, I felt like I needed to hang on. The slope was so high. I don't know how anybody with any limitation in their walking ability gets into their seat. It was treacherous, and I kind of wanted to survey it and see what it was, but I didn't have my 4-foot level with me. But cross slope can be a really difficult thing. So we try to maintain a pretty flat cross slope. Now remember, that's a 2% max. It doesn't mean that you lay that every time. So if you have a steeper longitudinal slope, you can do your users a favor by flattening up the cross slope a little bit. So our goal with cross slope is to provide drainage, but it doesn't have to be maximized at 2%. So remember that. I will always emphasize the maximum, but clearly we can work within a range of cross slopes as long as we have drainage. Here's a great example of where we have a problematic longitudinal slope. It kind of looks like there's a little landing here, probably to accommodate that entry. But the longitudinal slope is to be maximized at 5%. When you have something like this, I don't know what this grade is, but let's say it's greater than 5%, then we are allowed to have a little bit of relief in the sidewalk cross slope, or I'm sorry, the sidewalk longitudinal slope, but that should be the exception versus the rule. Also, as I talk about obstructions, you can kind of see here where the fence post is kind of sticking out, or the column is sticking out a little bit. We want to minimize that, and if you do have obstructions, still need to maintain that 4-foot minimum pedestrian access route. Here we have an independent alignment, and you can see there's a little bit of retaining wall here and some shoring, probably to accommodate the fact that the longitudinal slope on an independent alignment must be maxed at 5% unless you're going to start putting in landings and handrails. All right, so we just talked about that. Like I said, to speed up a little bit, we'll go through some of these things that, we'll go past some of these things that we don't need to review. There's our standard for where we can have, or where we're required to have a landing. So 8.3% maximum longitudinal grade, and if we have that, then we have to enter into some different design constraints. You need to have a landing everywhere that there is a raise of 30 inches in elevation, and need to have handrails when we have a change in elevation greater than 6 inches. So we try to stay away from this condition because it's a challenge to navigate, even for somebody with a stroller and a wheelchair would be especially difficult. And so there's standards that we try to abide by. A pedestrian access ramp is a ramp, but does not fall under the same standards that require a handrail or other provisions. When you do have a longitudinal slope that starts to get towards the maximum size, especially anywhere that would be non-expected, an advisory sign would give clue to somebody coming that, hey, we have a weird thing happening here and we're going to have a challenge for you. Also, as I mentioned before, if you have a longitudinal slope which is excessive, you may want to flatten up your cross slope in order to help the traveler. I teach highway design here at the university. The way we lay out these grades is usually controlled by the profile of the road. When you get into an intersection, then you got all kinds of weird things that start happening. But let's say in between the block, you can use this space between the edge of sidewalk and the top of curb to accomplish that change in cross slope if needed. So sometimes you don't have much latitude with your typical section, and so you end up with an elevation at top of curb that is pretty much fixed. If the elevation at the back of curb is such that you're going to exceed that 2%, we recommend that you take it out in what we would consider the berm or the boulevard. You don't always get a berm or a boulevard. Lots of times we have things that, conditions that are existing where there's no separation between top of curb and sidewalk, and then we have to do some other things. Another reason that we advocate that boulevard is it provides a place to take out some of the cross slope and elevation challenge, but it also provides a buffer for somebody who's using the sidewalk, as illustrated here. All right, so here we have what I would call a boulevard. This is a pretty typical section, pretty typical in many developed areas. And the benefit of having that boulevard is it provides a zone. This is labeled as furniture zone, not because that's where you store your old couches before the garbage guy comes, but which you could, right? But we call that the furniture zone. It's a lot more apparent in the next picture. If you think of downtown Rochester or downtown St. Paul, anywhere you have furniture or things that are extra, things like bus stops, benches, well, let's take a picture. Bus stops, benches, garbage cans, signs, kiosks, all of that, those belong in the furniture zone, okay? So we see a whole bunch of clutter here, things that I just mentioned. We got light poles, we got all kinds of stuff. That's a great place for it. So the furniture zone accomplishes two things. It allows us to keep our pedestrian access zone clear of obstructions and at that minimum width, and it allows for all the extra stuff to be out here. Now, many commercial areas also have a need for a frontage zone. So a frontage zone is where you're going to allow for the doors to open, where you're going to have landings and staircases into buildings. You might have some furniture in the frontage zone as well, but the most important thing is we maintain this unobstructed pedestrian access route. Not necessarily through the middle. Brady talks about at the Nicollet Mall, because the road itself winds, the pedestrian access route may also wind. So it doesn't mean that we have to have straight, we haven't said that yet. It means that you have to provide clear and unrestricted access.
Although straight really helps.
Straight helps, but you don't always get straight, right? So, thank you. Again, we mentioned before that we may need a frontage zone. Again, this is a nice typical showing. We have the curb, we have a buffer or a furniture zone. Then we have this clear, unobstructed pedestrian access route and the frontage zone, or I mean the furniture zone. The frontage zone, I did say it right, all right. Protruding objects cannot become a nuisance for people in our pedestrian access route. So when we have something like an old phone cabinet or a planter or a walk-up window to a bank or something, that cannot protrude into our pedestrian access route by more than 4 inches. Clearly, you can understand why. We need to make sure that if that does protrude, we have another 4 feet for somebody to get around it. Likewise, if it's something that can be approached from the front, it shall not protrude more than 12 inches into the sidewalk. Watching that video this morning of the woman with the cane really illustrated how we need to think all the way to the sidewalk, right? So a lot of times that sign for the church just made me cringe because it was, we've seen things like that without thinking about who's going to need to get a hint that that's coming. We can make obstructions for people without thinking about it. Here's our sidewalk. Remember, it has to be stable, firm, and slip resistant. However, as we enter into design, we also have to think about things like vertical deflections. This is a pretty common sight around here where trees have now gotten bigger and bigger and the roots start to push up the sidewalk panels, causing that lip to exceed the 1/4 inch in vertical displacement. We didn't really talk about pavers too much. Some of you have cobblestones, some of you have pavers, remembering that they're a maintenance challenge, that if we have 1 or 2 pavers out of tolerance, that can be a real problem for tripping and for water collection. They're painful for people in wheelchairs to go over, especially people with spinal injuries. It's just a da-da-da-da. I've pushed my dad many times over a non-continuous surface, and it's just not attractive. So they're still allowed, but we get a lot of questions about that in the last few classes as to if pavers are something that should be in the route. I can see Brady wants to talk, so I'll let him do that.
I just want to add something about pavers. At this point, they are still technically compliant, although there's a better choice to use. And in the future, there's a new sort of roughness standard that's going to come out. I don't know when, but it's going to sort of be used to help determine whether it's compliant or not. On projects that we've worked with MnDOT on, MnDOT has been saying no pavers in the right-of-way, or in the access route, period. And so we may go that way where it is, can't do it. So even, we had a couple projects where we had pavers, spread across the width, kind of a decorative band or so. Get them out. A lot of times you'd see them where maybe the ramp of the curb ramp is concrete, and then there's pavers on top. Well, technically that's in the landing. We're getting them out of the access route almost pretty consistently now. So for the time being, be aware that it's strongly discouraged, and we're probably getting to the point where they won't be allowed in the access route at all. Questions about that?
This is that bevel detail that Brady talked about. Brady, does this come from the MnDOT standard plan? I think it does, doesn't it? Not sure where this comes from.
No, that's the Minnesota Accessibility Code, I believe.
Okay, so the vertical deflection allowed is 1/4 inch. Brady mentioned a bevel allowance, and this is the detail for that. So if you have a bevel at a 2-to-1 or at a 1-to-2 that goes and smooths that out, that's okay. It may still be out of tolerance, so just be aware of that 1/4 inch vertical deflection limit. Also, as mentioned earlier this morning, we have a 1/2 inch opening tolerance. In addition, if your grates or castings have that 1/2 inch opening, make sure that they're placed appropriately so that the opening is perpendicular to travel. Notice that putting them perpendicular to travel on a crosswalk will make them parallel to travel for a biker. So there may be places where this is not a good idea, in which case go to that MnDOT ADA guidelines homepage and you'll see a detail for an appropriate plate or a casting in an area like this where the openings are much smaller. There's other standards that you can pick from for approved castings. Here's an example of how the wheelchair can get caught in there. So there's many situations where the grate selection has impact on the pedestrian access route. Bus stops, remember bus stops must not slope greater than 2%. And the width has to be at least 5 feet. Also, the transverse direction from the bus door that is allowed for access is 8 feet. So that could extend beyond your sidewalk. So in areas where you have bus stops, you have to be cognizant of that requirement as well. We'll take a break here in a few minutes, so bear with me. Remember, the pedestrian access route is lovely in the summer. It also has to be lovely in the winter. I think somebody brought up maintenance before. Somebody even was looking ahead enough to talk about something we'll talk about, which is the maintenance access route, a 6-foot clearance space required for snow removal. Here we need at least 5 feet, right? So for somebody trying to get on this bus, it would be impossible. If they were in a wheelchair, it's clearly hazardous for somebody who's not in a wheelchair. So communicating with your maintenance workers and staff about what's required for your accessibility is really important. What I said earlier, I really meant. When we publish our final guidelines, and it's on the Local Road Research Board website, I would very much recommend anybody here who has any kinds of access to your maintenance staff, you have a brown bag or you talk to them about castings are important, openings are important, snow removal is important, because people are very interested in doing good, but if they're not made aware of it, they may not think about things like this. There we just have a beveled repair on a joint. All right, so I think because we're entering into looking at the standard plans, let's just take a short break. I know everybody wants a long one, but we're just going to take 10 minutes. When we come back, we're going to look at standard plan 1 of 4. And so really, just like 10 minutes, at 2:10 I'll start talking again, and we'll start going through these standard plans. Keeping your expectations at a point where we can't cover them in deep detail, but I am going to show you where things are. All right, get right into the driveway crossings. As promised, that's details listed on sheets 1 of 4. These are the MnDOT standard plans, and while I've used standard plans before, they certainly are comprehensive. There's lots and lots of stuff in there that you may not need to even look at. Most important things on this sheet are, first off, the 3 details that I'll show you shortly are here, and these are 3 common driveways. We have the perpendicular driveway, which is lovely if you can get that. We also have tiered perpendicular driveway. Those are the 2 most common and they're controlled by the width of your boulevard. The note over here that I want to call out is note 8. I'll show you an example of that shortly. Note 8 specifies that the 5-foot minimum pedestrian access route is the standard through driveways. If feasible, you may have to widen the driveway width to match the approaching sidewalk. You may also have a challenge where you can't get a 5-foot pedestrian access route through a driveway area, in which case you are allowed to reduce that. And we'll show a picture in a few minutes of an area where the pedestrian access route did have to be thinned out a little bit. Here's a nice perpendicular driveway. Again, this is kind of dictated by the fact that there's a boulevard and there's lots of space here, presumably, to meet your elevation change requirements from gutter grade to edge of sidewalk. So the elevation change can happen here as long as it meets a maximum standard, and the cross slope through here is maintained at less than 2%. So not only do we worry about the cross slope here, but remember, a lot of times going down into a driveway, you might be tempted to go down and up. That's okay as long as this longitudinal grade is maximized at 5%. Doesn't change just because you're going through a driveway. Here's a nice picture of a perpendicular driveway. Obviously there's lots of room here. Doesn't look like there's a significant change in grade, although we can't really tell. We have adequate horizontal distance to meet this change in elevation and still staying within the driveway grade criteria. And then we take out a little bit of right-of-way behind the driveway in order to match in. A perpendicular offset driveway is required when you don't have the pedestrian access route space to go through the driveway without violating 2 of the maximums. One is the cross slope at 2%, and the other is longitudinal slope at 5%. So the elevation changes such that this grade is exceeded or exceeds 5, or the cross slope is such that that exceeds 2. In that case, you have to pull the driveway up and over. This is okay, not a big problem to design. The challenge is you have to acquire additional right-of-way. Plus, more concrete, so it's a little bit more expensive. These 2 details are in the upper left-hand corner of the first sheet of the standard plan. Here's an example of where I'm guessing, I didn't design this, but I'm guessing that the gutter grade and this elevation here were such that a maximum slope of, I assume that's a commercial driveway, a maximum slope of 10% was exceeded. So in a couple slides from now, we'll see that that slope is maximized at 10% for a commercial driveway, 12% for a residential driveway. So when that happens, this designer had no choice but to pull back. Obviously, there's some kind of right-of-way issues here or removal constraints because the sidewalk doesn't go back further. Another option would be to pull this back, similar to the detail I showed you prior. So that looks kind of funky, right? It looks funny, but it's perfectly acceptable because we see in note 8 on this set of plans that if the pedestrian access road has to be reduced to 4, it's okay. It's just not optimal. Anybody ever seen anything this weird in their whole life? Yeah, you see that kind of weird stuff all the time. So it's okay as long as we maintain the access road. Here's a parallel driveway. Again, this is okay as long as these slopes are maximized at 5%. When these slopes exceed 5%, then it becomes a problem because now it's a ramp, right? And so, but it's going to a driveway. It's not going to a access ramp. So a parallel driveway is okay. What we have to watch here is that the grade down is less than or equal to 5, the grade up is less than or equal to 5, and the cross slope is maximized at 2%. This is not super great because it means somebody who's in a wheelchair or otherwise impaired has to go down and up, but it can be okay. So here we see an example. Again, presuming that these grades are less than or equal to 5%, it's an acceptable part of the pedestrian access road. Driveways built like driveways encourage slower speed turns from the cars. Drivers built like roadways exceed or encourage less respect for pedestrians and users of the driveway. I mean, that's pretty clear, right? Here it looks like, hey, this is the zone that the pedestrians belong in. Here it looks like, hey, get out of the road. This is where the cars belong. Wouldn't you agree? So this is 100% okay. Brady and I both live by Wayzata. I pass tens of these on my way to church and the bank every day, and they all look just like that. There is no requirement that you maintain the sidewalk through a driveway, and there's no requirement that you put domes there or a pedestrian access ramp. The ramp would be required if, for some reason, you had an elevation change such that this exceeded 5%. Then you would put a ramp there, right, Brady?
Right, so I think we get a lot of questions about are truncated domes required at this location. They're not required at driveways, but if you end up having to put ramps in there, then you put the domes in. And the whole point is if it is built like this, where the sidewalk doesn't really dominate, where the roadway dominates, you still need to meet your slope and surface requirements. Mm-hmm. So that cross slope still has to be 2% max as you're going through the driveway. Extremely common to miss, right?
Oh, yeah.
In the previous one where the sidewalk keeps going through, you just construct the sidewalk, it's the same, it reads like a sidewalk. Here, even if the sidewalk doesn't go through, you still have to meet the PAR requirements.
Yeah, those of us that have worked with contractors or just worked with constructability, here, unless you have a profile for this driveway or some other kind of added design feature, it is really hard to maintain that cross slope through there, right? I mean, the contractor's going to grade it. Even if you check it, it's hard to maintain a slope when you're they're going to pave this longitudinally. They're not going to pave through. So it's a really hard thing to maintain the cross slope requirement on something like this. Now that doesn't mean that these aren't all over the place. They are, right? It just means that when you do your transition plan, this would be something that you'd have to measure through, right? We did those at the university. So we know there's lots of stuff out there that is not necessarily 100% compliant. All right, this detail is in our next handout. which is in the pedestrian curb ramp opening. And so this is the handout 1 of 6. Don't worry, we'll come back to this one too. But in 1 of 6, in the lower left-hand corner, this is where we start to talk about the ramp grades. So if the longitudinal slope exceeds 5% up a ramp, then we have to have a landing. The maximum ramp slope is 8.3%. Maximum length is 15. We already talked about all of these. So now we'll talk about the pedestrian curb ramps. In the lower right-hand corner, you also see a legend. The important things about the legend, remember, just like a typical detail, a standard plan is trying to do a lot of stuff with one figure. So the steep slope isn't necessarily always going to be there. If you have a flat or a low change in elevation from gutter to where you're matching in your sidewalk, you may be able to accomplish much of this construction with flat slopes. Flat slopes are between 2 and 5. A steep slope is between 5 and 8.3. What you will notice on the standard plans is at the top of a steep slope, you're going to see a landing, and the landing is indicated by this hatched area. Okay? So keep in mind that there's different situations. You may or may not have a steep slope. It's not like you have to build a steep slope, but if you have a steep slope, you have to allow for a landing. Also remember that a landing is going to be shown on any of these details where you have a change in direction or you have more than one direction. Here's your sheet 1 of 6. So here's the legend down here. The important note right here. It doesn't even have a number, but it's about the 6th or 7th paragraph down. It says, to ensure initial ramp and initial landings are properly constructed, landings shall, not should, but shall be cast separately. I can't read that, my eyes are too bad. Follow sidewalk reinforcement details on sheet 6. So there's your requirement that landings be cast separately. From a construction point of view, when the landings are cast separately and they're cast correctly, then all you have to do is match elevation, and you won't have weird kind of humps in your curb ramp openings, and you'll also be able to meet the slope requirements much easier. Let's see what else is listed here. I guess we'll just go through each one of these. Here's the perpendicular ramp, the tiered perpendicular. The difference between this one and this one is where you have a boulevard and where you don't. Here we have a parallel ramp, which looks an awful lot like a parallel driveway. So again, landings are required everywhere that you have a change in direction. So even though this looks like there's no change in direction here, there actually is, because somebody would need to make a turn there. So here's the landing. The landing has to be relatively flat. It cannot have a cross slope greater than 2%. It's placed where there's a change in direction, or the slope is greater than 5%. And it's also required if you have an inverse grade greater than 2%. So this is meant to show slope direction. So if you're coming up and you hit a 2% in the other direction, you also need a landing to take out that grade break. All right, let's go through the curb ramps. I'm going to go through these quickly, and then Brady will stand up to give me the clue that it's his turn to come over here. And he'll talk about prioritizing and how you choose one over the other, okay? First off, perpendicular ramps. This is a really easy ramp, pretty easy to figure out. Again, the landing is only required here if this is a steep slope. If this is a flat slope, we can have the ramp come straight out, in, and the elements are listed in the detail up here. MnDOT also gives guidance in the standard plans as to where to take out this curb height. So at the curb cut, we're at 0, and then by this point here, we're at full height. Tiered perpendicular, again, this looks just like a perpendicular, except now we have, well, for one thing, it goes in this direction, but this is an example of where we have a boulevard. Here we have a flare. This would be considered a non-walkable flare at a 1 to 6. We have a change in direction, so regardless of any of these slopes, we're going to require a landing at the top. Parallel ramp looks like a parallel driveway, except it's a lot skinny, or it's a lot shorter. Here we have a landing at the bottom because we have a change in direction coming out through. Here we have a fan. This fan alignment, which is middle of your, the top middle detail, this is required where we have not enough space to get the curb up to a minimum height between, and we have a change in direction from 2 directions, and we also have a 7-foot minimum radius at the back of the curb. We understand that every intersection is different based on the edge of the curb, the edge of the sidewalk, and the radius of the back of the curb. So that's why, if you let me go through all these, Brady will talk about the process for laying out the appropriate curb opening. This is a modified fan. It looks just like this one, except the back of curb radius. Here we have enough right-of-way to accommodate a 7-foot back of curb radius. Here we don't have enough right-of-way, so we have to cut a 90-degree angle, or whatever angle that is, to fit this curb in here. These are areas, just as an FYI, this is where my students would get confused as to where the landing is, right? So when you have something like this, pretty easy to figure out where the landing is. Landing's pretty easy. But when you start getting into these fans and depressed corners, it gets a little bit more confusing. MnDOT will show you where the landing is on the detail with the hatched hatching. Here's a depressed corner. This is acceptable. It just might cause for some drainage issues down here. So again, similar to the fan, but we have the landing at the bottom like that. And then lastly, we have the least desirable curb opening, which is a diagonal ramp. The reason this is the least desirable, and this is in your upper right-hand corner, you can see the note just to the far right of it. It's only to be used after all other curb opening options have been evaluated. The reason it's a challenge is because it deposits the user right between 2 crosswalks, not directionally into either one. So this requires the user to make a hard left or a hard right just to get into the crosswalk. Moving on into the directional ramp. So this is on sheet 2. Brady will talk about the truncated domes and how those are selected, but basically we have the combined directional, the one-way directional, and then we have some different options for back of curb truncated dome placements. You had asked me, somebody had asked me, you did, about the directional ramp with the walkable flare. We'll talk about that and assure you that you probably put it in okay. So here's the standard one-way directional. This one is confusing because we get this weird kittywampus kind of triangular shape. Brady taught me this is called the Winona curb, so now you guys all have that knowledge too. MnDOT standard plate specifies that this be placed integral with the curb and gutter. So I didn't bring it up earlier because it would have just been confusing, but we did have a picture where there was a joint through here. That is incorrect. Our inference has been MnDOT wants that because if you put a joint here, this is going to break pretty quickly because you're going to have differential movement there. So this is all placed as one piece, and that's part of the standard detail. This truncated dome is placed where the full width is first available. So you can see right here at that point is where you're able to put in the truncated domes. Remember that the gutter grade is at 2% maximum, but when you get into these weird skew lines where we don't have the gutter going exactly perpendicular to the longitudinal direction of travel, you are allowed to go up to a 3% slope when you have a weird skewed gutter, and that's specified in the standard detail as well. Directional with detectable warnings at the back of curb. These are shown in the middle here. How do you know when you're going to use radial truncated domes versus this rectangular placement? It all depends on how much distance you have between back of curb and those truncated domes. This would be something you could easily figure out with CAD and placing these in. so that you would know if these are going to work or not. These are cheaper, but also take note that the full width of the pedestrian access route has to be covered, so you may actually end up placing more dome than when you have the radial section. Like I said before, we do have the typical or the standard plate for the truncated domes, not in your handout yet, but we'll add that when we publish the PDF. The criteria is that this distance between back of curb and the dome should be 3%, or I'm sorry, 3 inches, excuse me, and not exceed 9 inches. So if you lay this out and this distance exceeds 9 inches, then you have to go to radial domes. Here's a nice example. Notice that cutting this radial truncated dome off here, I mean, visually it looks like it's going to be okay on this edge, but it leaves a little pie shape on that edge, so that would not be acceptable. When you have the walkable flare, depending on if it's an area that you expect people to traverse over to get down to the ramp, then the maximum slope is 8 to 10%. When do you come up and interrupt me? Pretty soon? Okay. All right. Well, I just don't want to zoom, but he won't. We've kind of gotten used to each other. Here's where we show one landing shared by 2 different sidewalks. The landing up here is used for 2 purposes: to accomplish a change in direction for this user here, or to accommodate the fact that this is a steep slope. Okay, a combined directional. This is a complicated one, but not a challenge to use. In fact, this is the first choice on this here because it provides clear direction as to which way the user is supposed to travel. So with the combined directional, we have this small pie-shaped wedge between. It offers a delineation between this route and this route. This here requires, though, that you have at least 5.5 feet from edge of sidewalk to edge of sidewalk. That would be impacted by your curb geometry. So if you don't have enough room, it's also impacted by the boulevard size. So if you don't have enough room, then you can't use this. You have to use the depressed corner or the fan, right? All right, now I know this is time for Brady because this is the slide. So he's going to walk through a hierarchy decision of which curb opening you use when.
How many of you have used these in design? Couple? Okay. So the reason I'm step up here and do that is, and walk through these, is because if you haven't seen these before, you just sort of get hit with a barrage of types, not knowing why one exists over the other. So I'm just going to, and it actually a really good job of identifying this one. The combined directional, as she mentioned, it is preferred because it's clear. You have a clear crossing this way using this ramp, this way using this ramp. This is preferred when you have 2 crossings at the same corner. The reason you wouldn't use it is if the geometry, as she said, the geometry or the curb radius doesn't allow you to get enough space between these ramps. So what a designer is going to do is you've got a sidewalk coming this way. You'd extend the edge of the walks through the curb line. Do the same thing with the other walk. Where the inside edge of the walks intersect the curb here and here, you're going to need to transition the curb at that 10% maximum rate, right, to get back up closer to full height. You need to get at least a 3-inch curb height in between and then hold it there for at least 6 inches. Preferably, you get up to a 4-inch curb and hold it there for 6 inches. So that's going to take a certain amount of space right here in order to get the curb back up to half height and back down by this curb opening. So if you can't do that, and MnDOT has calculated it for you, you need at least 5.5 feet, preferably 7, of radius length in between these ramps. If you can't get that in, then you turn the whole corner into the ramp, and you're looking at a fan, modified fan, or a depressed corner.
Can I ask you a quick Brady?
Yes.
What is considered the back of curb on the long side? It's for an integral, right? Yeah, so you're coming around the radius. Where's the back of it? Do you maintain that through there?
Well, remember, this is port integral.
Yeah, so where does that 9 inches come from? Maximum 9 inches for the...
I'll get there.
Oh.
We're talking about 2 crossings right now. It's easier to think of if we look at 1 crossing just at a time.
Compliant, obviously.
Yeah, I'll get there about the 9-inch requirement. So, and then like I said, if you can't achieve this distance where you get up to half curb height and then back down, you'd make the whole corner a ramp. You're looking at a depressed corner or one of the fans. I'm going to switch to those fans quick, so look away if you don't want to see the screen go. Okay. A fan is preferred over a depressed corner because you tend to have some drainage problems near the flow line, the low side of a depressed corner. So a fan is going to be preferred. What's also going to help you make the decision of a fan or a depressed corner are your tie-in elevations. So if you've got a higher elevation towards the back of the ramp to tie into, it's probably going to be a better fit to achieve part of your elevation gain out on the front here where the ramp is. See, we've got these Fs for flat slope. If you need to, they can be S slopes. You've got a landing here, it's just preferred to have it be flat. So then you make up part of your elevation gain to here. If you've got a right-of-way problem, as Ann mentioned, or maybe it's even a building right there, or you've got a higher elevation difference to make up, you can use this V-curb off the back. So you can kind of ramp up, landing, and then you have a V-curb. Helps you achieve a greater elevation difference from flow line to where you're tying in at the back.
You don't need V-curve though, right? You can grade it just like that.
Right.
Yeah.
You wouldn't need it. It's just another option. As long as you maintain that 4-foot width here within your landing. The depressed corner, again, it's the last preferred option because of the potential drainage problems. But a lot of times if you've got very little elevation change from your curb to your tie-in point, that's the option you're looking at. So let's look at if there's a one-way crossing. We've talked about the 2-way crossings now. If you're looking at a one-way crossing, if a perpendicular ramp works, put it in. It's the easiest one to control. If your sidewalk is, if you've got your sidewalk against the back of curb, it's a mid-block crossing, a parallel ramp is very common. So those are sort of easy ones that are fairly obvious. Anytime your ramp is coming to the curb line in a perpendicular fashion, you put in the perpendicular one. Mid-blocks and against the back of curb like this, parallel seems to work really well. Where it gets tricky is when your ramp hits the curb at a non-perpendicular parallel angle. That's when we use the directional. Sorry for the flipping. So here's where we have the directional. You can see the angle with the curb. The curb is at you don't meet it as purely perpendicular or parallel, so use this type. This is a standard one-way directional. As Ann said, you put the domes in the first time you have the first available full width of the sidewalk. This piece is your integral piece. We're not quite to the 9-inch part yet, but we're close. The requirement here is if you're within 5 feet between the front of the domes and the curb. If you're within 5 feet, this is okay. This is a good way to do it. If you're based on the radius here, and if you have a boulevard at all, you may exceed that 5-foot maximum. In that case, you put the domes at the back of the curb.
Like that.
Like this. And so in this case, you'd have the corners 3 inches off the back of curb, and you'd cut that cord across like this. If that is more than 9 inches from back of curb to front of domes, then you need to do radial.
Did that change? Because as a construction guy, that is not the rule we had to abide by for many years. It had to be 3 inches or less, and if you couldn't get it, you had to use radial domes.
Since I've been doing a lot of design, it's been like this. Todd, do you know when this was changed? Or might it?
Well, that was in the second version of standard plan 4 years ago at least.
Okay.
Yeah, and these standard plans are dated 17, so.
That help? So there's a progression of sort of steps, usually starting with extending the edges of your walkway, seeing how they interact with the curb. One other thing I just want to illustrate. So Ann mentioned this. I'm going to just going to repeat it in case that maybe a second time makes it sink in again, makes it sink in.